All right, so I'm recording now. So first off, I just want to give you all a brief introduction into Google Colab. So Google Colab's really great because it has a lot of Python libraries pre-installed. And so if you were trying to get into like machine learning or deep learning on your own, it's likely that you would have had to install Anaconda and then install TensorFlow, Keras, or like PyTorch through Anaconda. But using Google Colab, all those libraries are pre-installed. And so also, um, if you run, I'll run the first cell line of code in a second, but when you run it, you'll notice up here, this will connect to one of the Google computers, and basically you will be able, basically you're not really running this on your computer. And what's really nice about that is that if you go to runtime and go to change runtime type, and while this doesn't necessarily apply to this workshop, you can use like a virtual GPU. And so if you're training machine learning models on your laptop, this is like a really easy and free way to do that. And so Google Colab's like a great resource if you're just trying to get into machine learning and learn it, but you don't necessarily want to download a bunch of programs onto your computer, or like use your own computer to train large networks. And so just to give you all an idea of the workshop structure, this workshop is going to cover Python basics like functions, classes, basic data structures, and then it's also going to cover NumPy, which is, if y'all, I don't know if y'all have used MATLAB before, but it's basically like a scientific computing library for Python. And so it's a library that's just good for handling like large matrices and linear algebra, but it also syncs up well with scikit-learn and Keras, which are the machine learning and deep learning libraries we're going to be covering. So in the next workshop, I will be covering scikit-learn, and we're going to be covering some basic machine learning processes like linear regression, or methods like linear regression, logistic regression. And then in the next workshop, I'm going to use linear regression and logistic regression to introduce you all to neural networks using Keras, which is deep learning. And so I'll also explain the difference between machine learning and deep learning in the next workshop. But really my goal is that everyone who attends this workshop series is able to have like a basic understanding of machine learning and deep learning, and hopefully just like a starting point to kind of, if you're able to establish an interest, hopefully you'll be able to go out on your own and be able to not like pick up stuff quickly on your own after this. So I'm just going to go ahead and get started right now. So first, we're just going to be covering functions in Python. And so functions really allow you to modularize your code. This is very basic, but instead of having to code like one process a bunch of times just by hand, you can code it once using a function and then call it a bunch of times. And so it's an important Python basic to know. Also, if you hit help and put any function within help, Python will print out like what arguments that function takes and really what that function should be doing. And so we're going to run our first cell. You can either run the first cell by clicking the play button here, or you can run it by holding Shift and Enter. Also, one more thing I wanted to mention before we really get into it is that Google Colab's in kind of like a Jupyter notebook format. And so that means like all of our code is in cells, which is really nice if you're getting into programming, just because it makes it incredibly easy to debug your code since you're not running a full program all at once. You're just running these cells. So here I made our first function. So when you make a function, first you have to start out with, you have to define it here. So it's important to give it like a meaningful name. So I named this function multiply, and multiply is taking two arguments, x and y. And so all it's going to do is multiply them, save them to variable z, and then we're going to return z. So each function is just going to start with this def, and then whatever your function is, the inputs to your function, colon, and then return whatever the output of your function. So here we're going to run this. So here we define the function, we set x and y to 5 and 2, and then we save the output of the function to m, and so we are getting 10 there. So if that's like, also if you have any questions, either like drop them on the chat or just unmute your mic and say something, but I'm not anticipating Anyone really having too much of an issue with this right now? So next, I'm just going to demonstrate using logical arguments with functions. So here we just have another function, and it's going to take three variables. So it's going to take, or three arguments, so x, y, and then c. And so c is going to determine whether or not we're going to multiply or divide using this. And so this is just a basic intro to like logical operators in Python. And so equals equals is checking if something is true. And so you wouldn't, basically one equal sign is assignment in Python, but two is for comparison. And so here, if c is equal to 1, then we will multiply. And if c is equal to 0, then we'll divide. And so we're using an if statement and an else if statement to do this. If anyone's unfamiliar with either of those, let me know if you want me to elaborate a little bit more. But basically an if statement just sets one condition, and if that statement is true, we execute a set of code. And if it's not true, we go to the next statement, and this elif stands for else if. And so it's like, else if this statement is true, then we'll run the code underneath that. And so you can keep going with the else, with the elifs, or you can just use an else. So here either elif or else would have worked fine. Just with else, you wouldn't be specifying a condition. It would just be, if not the first condition, the second condition. So I'm just going to demonstrate. In the first scenario, we have x and y equal to 5 and 2 again, and c is equal to 1. And so we're going to multiply x and y, and we are going to print that. And so print is how you view your output in Python. And so we're going to see 10 for the first one, which makes sense, and c is equal to 1. And then afterward, we'll assign 0 to c, and we will see that we divide 5 by 2, which gets 2.5. So you can also use like asterisk args to pass like a variable number of arguments to a function. And so here we're just going to display a bunch of strings using that method, but that's more of like a Python tip, and it's not something you'll really have to do a lot with machine learning projects. But here it just demonstrates we pass more to the function, it passes that to print, prints more, and see, since we were able to call the function multiple times and we separated that by these sets of commas, then we can send multiple arguments or multiple iterations of the same argument to this function. So now I'm going to cover some basic data structures. So the first one we're going to cover is a list. And so a list is just a set of like comma separated values. So here I have a list of numbers, and then here I have a list of characters. So we're just going to shift enter to run this block of code. Also, one thing I should have mentioned earlier, if you click over here, you should be able to see the table of contents. And so you can click to any section in the notebook. And also, like, since I shared the notebooks, feel free to like come back and use them as a reference. That's really one of the nicer things about Google Colab. It's basically like a Google Doc for your code, and it comes with a bunch of libraries installed, and you can also use a GPU. So it's very nice. So yeah, we're just gonna run this here. Okay. The first thing we're gonna do is len returns like the length of a list. And so this is like important when you're using arrays for machine learning. It's often like important to see like how much data is in an array, or like how long an array is. And so like len is something you'd use for that. And so all you have to do is len, and then parentheses, the list that you'd like to pass to it, and then see, we'll run our code. And since we had 4 numbers in the list, it returns 4. So if you add brackets behind a list and put a value in there, you can index a certain part of the list. And so in Python, everything is 0 indexed. And so 0 will access the first entity in our list. And so 0 will get 1 here, which you can see here. So we're just printing the first item in the list. And then you can also use a colon between 2 values to pass a set of values from a list. So here we're passing 0, we're passing the first 3 arguments of the list using 0:3. And so we can see we have 1, 2, 3 here. So that's list indexing is important, especially when you get into messing with like large like vectors and matrices. But I guess it's not so important for certain projects, but it's essential to know that in Python. It's something you absolutely need to know. Moving on from there, um, you can concatenate lists together by using the plus sign. And so here we take the list of numbers from here, and then the list of characters, which we defined up here, and we just add this plus between them. And so that will basically add the list like end to end. And so I'm just going to run this real quick and see in the first line, it printed uh, all of our lists. Also, I saved the list to another variable. So we printed mix list. And so you can see the values in both lists were concatenated together, just attached together at the ends. And then you can also do list repetition just by using the asterisk. So it's just like, we're just multiplying the list by 4 basically. And so instead of like multiplying each value in the list by 4, it will repeat the list 4 times. So here we do that on our number list, which was defined up here. And so we just have 4 sets of 1, 2, 3, 4. Okay, so I think that was a bit of a repeat. So you can also, I guess I'm showing more examples of indexing lists in Python here. And so as we went earlier, using 0, we'll just index the first entity in the list, and then 0 to 3 will index the first 3 entities in the list. And so you can think the last one is being like 3 minus 1, which is 2. And so we go 0, 1, 2. And then if you just use a colon, it'll return the entire list. So here we're getting the first element, here we're getting the first 3 elements, and then using a colon returns the entire list. And then also it's important to know how to update list values. And so if you set a value to be equal to an indexed component on, or an indexed entity on a list, then you will assign that value to that part on the list. And so that's kind of, it's just important to know that if you're wanting to change values in the list. So this is how you update values in the list. So here we're using 1, which is the second entity in the list, because everything in Python is 0 indexed, and we're setting that equal to 10. And so we print it here. The list is exactly the same, except that the second entity in the list is 10. Also, you can append values to the list, and so that will add a value to the end of the list. And so here, normally this would be done like inside of a for loop if you want to add like a bunch of values to a list. So here we're just, it's also a method, and so you're just going to do numList.append 5. And so that's a really important method to know when you're messing with lists. And so we can see here we take numList and then append 5 to it. And so we have 1, 10, 3, and 4, and then it just adds 5 to the end of the list. So that's it for lists. If anyone has any questions, either drop it in the chat or speak up. Now we're going to move on to tuples. So tuples are a bit less flexible in Python. Also, if you want to start an empty list in Python, I should have put this earlier, but you can just do just have a set of empty brackets. And so if you don't know what you're going to put in a list, you can basically just initialize it using a list of empty brackets. And so whenever you want to put values in a list, you have to use the brackets. The brackets indicate that the data type, the data structure we're using is a list. Here with tuples, it's parentheses. But one thing that's important is if you're just going to put a number inside the parentheses, if you just put a number or one like character in there, it's not necessarily a tuple. You have to make sure to include a comma so that Python knows it's a tuple. So here we're just going to initialize a number tuple, a tuple of characters, and then an empty tuple, and then one mixed tuple. So tuples are immutable, so you cannot like go in and just change values in the tuple. You can't just go in and update them. But a lot of arguments that are passed around in like libraries like Keras are using tuples, so important to know what they do. You may see quite a few error messages regarding tuples. So First, we're just going to go over how to index tuples and how to get the length of tuples. So we're just going to take the length of the number. Give me 1 second. Okay. Give me one. Okay, got to run your code. So I had forgotten, basically why that didn't work is I didn't initialize num tuple by running this code up here. So keep that in mind when working with Jupyter notebooks. All right, so here we're just returning the length of the tuple. And so there are just 3 values in the tuple. So length will return all 3 values. Tuples are basically indexed in the same manner as list. And so you're still going to use brackets after the tuple and then specify what values you want. Again, they're 0 indexed. So 0 will grab the first value in the tuple, and then 0 through 2 will grab the first 3, and then a colon will grab all of them. So as you can see here, we're grabbing 1, 2, and then we're grabbing 1, 2, 3. And then also, as I said earlier, tuples are immutable. And so if we run this code here, you'll notice we should get an error. So here it says type object does not support item assignment. And so basically all that's saying is you cannot, well, I shouldn't have done that, but I can. So tuple does not support item assignment. And so basically all it's saying here is that you cannot update the values in the tuple. And so that's all I've demonstrated. We're trying to assign 10 to the first location in the tuple. And as I said earlier, tuples are immutable, so you can't do that. But yeah, that's all there is to the cell. But if we run again with those commented out, also in Python, since this is like a Python's basic workshop, if you put like this number sign before any code, the code will be a comment. So you'll notice I have a lot of comments in the code, just so if anyone's going through this notebook without, like after the workshop, that it's very clear like what all the code is doing. So if you're working on a project on your own, it's really important to do a good job of commenting all the code. Also, so we can, despite not being able to assign new values to tuples, we can concatenate tuples together. And so here I'm just concatenating 2 instances of our number tuple and then printing that. And so if we run that, we can see we're getting 1, 2, 3 twice. So basically we're just taking both of our number tuples and stacking them together. And so that's concatenation. You can concatenate tuples of different data types. And so here I've done that with our number tuple and with our tuple of characters. And then you can also perform repetition like we did with lists. And so here I set a variable, or I set a tuple that's just stands for like repetitive number tuple. And so whenever you're making variables in Python, it's really important to give them meaningful names. So when you go back and look at your code after, like let's say you work on it for a while and then go away and come back, that it's still like clear to you what you did. And so it kind of is in the same vein as like comments. Your code should be understandable. You shouldn't be the only one that's able to understand your code is really what I'm trying to get at. And so here we just repeated our number tuple 4 times. So we're saying 4 instances of 1, 2, 3 in this tuple. And so that's just a brief introduction to tuples. And so next we're going to cover dictionaries. And so dictionaries are a very, very useful data structure. They're really great for like, you can kind of pass them between functions, and it's a way to like compress data and send them to other functions or to other modules. So it's really, really helpful to know how to use dictionaries. And so you remember we started a list by using a set of empty square brackets. We started a tuple by either an empty set of parentheses or parentheses and a number followed by a comma. Here we're going to initialize a dictionary by just an empty set of brackets, of curly brackets. And so here I'm just initializing an empty dictionary. And then also I just made a dictionary for UTSA. And so what's great about a dictionary is it's kind of like data with context. And so it's a set of keys and values. And so you can call a key in a dictionary to access the value in the dictionary. And so like here, I just put UTSA dict. And so if you wanted to know what school was in the dictionary, you could index it with school and that would be the key and UTSA would be the value. So here, school is the key. You follow that by a colon, and then UTSA is the value afterward, and then just separate them by commas to initialize the dictionary.
I have a
So
question
here's
about that.
like just another way to do that. You can also use dict, the dict constructor to do that. So you don't have to use curly brackets, but I think it's probably more common to use curly brackets. And so see both methods of starting the dictionary yielded the same values. And so here again, school, UTSA, that's a key value pair. Mascot, rowdy, key value pair. Grad year, I just put like my graduation year, so 2022.
I have a question about that.
Uh,
So are
sorry.
those like objects? Are those like objects
Yeah.
basically?
Well,
Okay.
like
Are they different from objects, or is that because I know in Java, JavaScript, objects are basically like that. I just don't know in Python if these are a bit different.
Python's object oriented, so yes.
Okay.
So as far as I mean, I could be, yes.
All right.
Okay.
Thank you.
Sorry about it. Yeah. So we're just going to start with school. Um, okay. So again, we index dictionaries similarly to lists, except you can't just put 0 and ask for a value. You have to use the key to access the value pair. And so here we're putting school, that gives us UTSA, mascot, rowdy, grad year 2022. And so you can also use the get method instead of using square brackets, but again, more space efficient to use square brackets. So I recommend just using those. But as you can see, using the dot get and putting school within the parentheses will get UTSA, just like school within the square brackets. So yeah. Dictionaries are immutable, which is also super useful. So if you pass them to a function, you can take values that are developed in that function and then put them back in the dictionary. And then, so dictionaries can be freely passed to functions, which is super useful. So here, just changing grad year to 2023. So all you need to do is say UTSA dict, square brackets, grad year is the key value, and then we're just assigning a different integer value in there. And so here, when we run this code, again, shift enter runs the code in one of these boxes. And also if you put your mouse like between two cells, you can add code or text. And if you want to make a table of contents, so I guess I'll just cover like markdowns really quick. You can just put text in here and it'll just give you, so it's another useful, like instead of, I guess some IDEs may not have this. And so it's just another useful thing to know, I guess, if you make your own notebook. And then if you follow that with a pound sign, like a normal comment in Python, then text will become a section. And so here, it's like a large section because I used one pound symbol, but you can also put 2 or 3, which will make it like a subsection. And so this is another good way to organize your notebooks. And one more thing is if you use sections like that, then you can just hide code and then run it back out again. So it'll help like declutter. If you're going through a bunch of code, it's another good way to organize. So that was more of a aside, but important to know. Or maybe not important to know, but useful at least. You can also add key value pairs to the dict. And so here I do UTSA dict, and then I specify a new key. I don't even have to like append this to the dictionary. And I'm an electrical engineering major, so I put EE, and I just printed UTSA dict, major EE. All good there, very nice. You can also remove key value pairs, so you can do that using the pop method. And so all you have to do is .pop and then put the key that you want to get rid of in there. And so since I added major, I just wanted to get rid of major immediately. So first we printed the UTSA dict dictionary with major. And so you can see electrical engineering showed up. And then after we popped it, we printed it again, and major is gone. So you can also get the length of a dictionary using len, again, very useful. You can, if you iterate through a dictionary using a for loop, then you can print out all of the keys. And if you, so if you just iterate through the dictionary, you're just gonna return a bunch of key values. But if you specify the dictionary and then index by the keys, you're going to get all the values from the dictionary. So here, first we loop through the dictionary just using for I in dictionary. So it's taking each key. And so we're printing each key, such as school, mascot, grad year. And then here, we're specifying that we want the keys to be indexing the values in the dictionary. And so here we get UTSA Rowdy 2023. So, and then you can nest dictionaries. I demonstrate that here. You just have to use the dict constructor and then just you kind of have to have these pairs in here, student one, so I specified student one up here. So student one is using this dictionary that just specifies their school and their grad year, and student two is specifying a different, or same school, different grad year. And here we nest the dictionaries. And so basically for student one, we have school, grad year, and then for student two, we have school and grad year as well. So not something that I use often, but maybe you'll find it useful. So another thing we're going to go over are classes in Python. And so classes are object constructors. They're kind of like blueprints for Python objects that you may be interested in making. Classes are very, very important to be familiar with. So this is an important section. So I'm just going to make I made a student class when I made this notebook. So you have to start with def, and then it's customary to start with, sorry about that, init. So it's 2 underscores and then init and 2 underscores. And so you have to start with self and then pass in. It's important to give like your arguments for the class, like valid names. And so for the student, I'm taking name, class year, and major. And so we're just specifying self.name equal name, self.class year equal class year, self.major equal major. So this is basically, we have like an empty student class right now after we run this code, but we can assign that class to variables and specify values within that class. So if you have like a bunch of students, you can just put like here, I don't know if anyone here's named Jeff, but I just put Jeff, student, and then you just pass in all of the arguments that are specified within the class. So I just pass in name, class year, and then major, so electrical engineering. And so you can, it's kind of like if you think back to indexing for lists or for dictionaries, you can do Jeff.name to get name, Jeff.year to get the class year, Jeff.major to get major. And so we just run the cell. Okay. Oh, okay. Just made an error when I made the notebook apparently, so sorry about that. But yeah, so Jeff.name returns Jeff. It's class year. So notice we're calling Jeff instead of student because Jeff is where Jeff's data is saved. Student is just a blueprint. So very important to keep those separate. So if you did student.name, you wouldn't get the right value, or I don't think the code would work. So you can create functions within classes. And so init will basically just hold the arguments that you want your class to hold, but you can also specify functions within that can receive other arguments. So this is another thing that's very useful and very nice about classes and makes them very flexible. So I'm just gonna run the cell. Okay. So here we're just going to specify, Jeff in the same way that we did earlier, and then we're just going to set this is just going to calculate the years that Jeff has left in school. So I don't know if I actually set this up right. Okay, so we're taking Jeff's start year, we're Okay, so ignore this code. I apologize, this is like an artifact from when I first started making the notebook. And so all we're doing is taking years left, 4 minus Jeff's class year, which we specified up here. And so start year, you just ignore, that's just an artifact from earlier. And so we're basically just taking 4 minus his class year, and then we're returning the years that he has left. So that this was a bit sloppy, so I apologize for that. I had a very busy week. Um, you can also create child classes that rely on arguments passed in from other classes, and so here we're specifying EE student, and we're passing in the student class for this class. So this is useful when you want to create classes that you've like, let's say you have like classes that are going to be similar, so you just want to use like a class that you've already made to help set up this other class that you're making. And so here we're just defining field, GPA, name, class year, and major. So self.field equal field, self.gpa equal GPA, pretty simple. And then class year and major are from student. And so you have to do super, parentheses, and then dot init, and then name, class year, and major to set that up for our EE student class. And then here we're just going to add, I just made this student Thomas. He's interested in power. He studies a lot, so he's got a 4.0 GPA. And then we just have to specify his name up here. So this part is the EE student class, and that's the child class. And then this part is sending the arguments to the first class we made, which is the student class. So as you can see here, taking field GPA, and then these arguments from the student class. So we're just going to print Thomas.name, Thomas, and then Thomas.field, field's power. Yeah, so if you have questions, let me know. And if not, I'm just going to go straight into NumPy if y'all are ready. All right, so first thing, you have to import NumPy. And so always import NumPy as NP. Basically, that just brings the library into your notebook. And then here, we're going to set up a bunch of NumPy arrays. And so NumPy's, it's pretty neat. I think in some ways maybe a bit more flexible than MATLAB. I'm like definitely not a NumPy or MATLAB expert. You don't need to use NumPy a ton if you're working on machine learning or deep learning projects. But if you're sending values to, or if you're working with like values or arrays in like Keras or scikit-learn, they can take NumPy arrays. So it's important that you learn NumPy arrays, and also scientific computing. Like basically, you're gonna have to do MATLAB for your classes, so it's just important to know these things. So here we're gonna start. We're gonna set up a row vector, and so we're just gonna put 1, 2, 3 in it. And so basically, these square brackets will set up a row within a matrix. And so I hope everyone's like familiar with matrices. And so since we just use 2 pairs of brackets, that's just specifying a single row in NumPy. And also you have to use like the NumPy array like constructor. So np.array will make sure it's a NumPy array. Otherwise, this would have just been a list of values, and it wouldn't have had the right properties to use some like the operations in NumPy, not functions, operations. So then we're going to set up a column vector. And so basically, you can think of each value in this column vector as its own row. And so again, the square brackets specify the row. So just have 4 and 5, 6. And then if we print those, we just get 1, 2, 3, and then 4, 5, 6. And then also you can just specify like a single value in a vector, but I mean, that's not really useful. So yeah. Again, if you're getting any errors, it may be because you didn't run a cell. And so whenever you click into a cell, Shift and Enter will run the code in the cell. Are y'all like following along in the notebook, or y'all are just kind of watching the presentation? Because like ideally the way I saw this working out is following along in the notebook, but both are totally fine. So I'm just curious, I guess. So drop that in the chat if you want to. Okay, cool. So obviously you can also make a 2D matrix. And so all you're going to do is specify 2 sets of rows here, and then you have to have a set of square brackets outside that. So we're just going to specify one row of 1, 2, and 3, one row of 4, 5, and 6, and then we print, and we get a two-dimensional matrix. So here's our row vector, here's our column vector, and then here's our two-dimensional matrix. You can index elements in a vector. Everything is it's Python. NumPy is Python, so they're zero indexed. So I think I meant to put this is not different, not very different. So here we're just going to print 1. So that's just going to give us the, this is for our row vector. So that's just going to give us the second element. So that's just 2. So for context, think of a colon meaning like well, it's not the same as indexing and lists, but my point is it's similar. A colon meaning, you think of a colon as meaning like everything in between. So if you want like everything between 0 to 2, you could do 0 colon 2, and here we'll get 1 and 2. Also, if you want every value after 1, you can do 1 colon. And so instead of like earlier we used colon to get every value on the list, here we're doing starting at 1 and then everything after 1, we want that printed. And so that's what we're doing here with the row vector. So here, notice that it skips 1 and then it does 2 and 3. So 2 is 1, we're starting at 1, and then there's only 1 value after that. You can also do everything before 2, and so 2 is kind of 2 represents 3 in our row vector. And so we're just grabbing 1 and 2, which are the things before 3. And then -1, specifying that as an index in NumPy will give you the last value. So in our row vector, and the last value is 3, as we specified up here. And so if you put -1, we're going to print out 3. 3 is going to be our output. Basically, not a lot changes with matrices. Well, actually, I take that back. With matrices, each row is kind of an indexed value. And so we put a colon, we're going to get the whole matrix. Going to put 0, we're indexing the first value, value in the matrix, which is technically this row of values. So we're just going to get 1, 2, 3 when we print that. And then when we do -1, as I said earlier, in NumPy, that's grabbing like the last value in an array. And so that's just going to give us 4, 5, 6, like we defined up here. Okay. Moving on from that, you can use, it's really important to shape and reshape are the most important things in NumPy. And so if you want to get the shape of a matrix, you can just do, or of a NumPy array, not a matrix, NumPy array. We can take row vector and then dot shape, and that will give us the shape of our row vector. And so here, our shape is 3 by 1. And so in NumPy, if you don't specify like a set of like stacked rows, you're just going to have like, it's not uncommon to have 3 comma. And then also if you have column vector dot shape here, well, wait a minute. Or yeah, our column vector is 3 by 1. Did I do anything to the row vector? I don't believe so. The row vector is 1 by 3. For our matrix shape, our matrix has 2 rows and 3 columns. So that's going to return 2 by 3. And then, so a shape just returns like basically the arrangement of rows and columns within a matrix or vector. So if you want to, if you're doing like a machine learning project, it's typical to have a design matrix that holds a bunch of examples, and then for all the features that you're defining in that problem, the data for each feature. And so it's important to know the shape of your design matrix before you make a model. And so in later workshops, we're going to use numpy.shape often. And then size will return the total number of elements. So that's just row times columns. And so 3 for our row vector, 3 for our column vector. Here I just specified row vector since it would have been redundant to do column vector, and then just 1 for our matrix size. And so our matrix is 2 by 3, 2 rows by 3 columns, 2 times 3 is 6. So it's of size 6. But shape is much more important to know than size. And then in dim will return the number of dimensions in the matrix. And so For vectors, the dimension is 1, since your data is just one kind of strand of entities. And then for a matrix, it's going to be 2, since we have 2 dimensions. Kind of, yeah. Okay. So there's a difference between like matrix multiplication and element-wise multiplication and NumPy. And so if you use @ and NumPy, that's matrix multiplication. If you use an asterisk, like normal Python, then that's just element-wise multiplication. So here, we're just taking the row vector and the column vector. And so what we're doing is the size of the, so I guess this is also going to be an intro to matrix multiplication if you're not familiar with that. If you've taken linear algebra, then you'll be familiar with that, or I'm sure most of the engineering classes cover matrices, or you have to use matrices. So here we're taking a matrix, or a vector of size 1 by 3, and we're doing matrix multiplication by a vector of a size 3 by 1. And so for matrix multiplication to work, these inside dimensions, 3 and 3, have to match. And you can think of them as canceling, and then we'll get a vector of like 1 by 1 dimension. And so 1 by 3 times 3 by 1 will yield size 1 by 1. So yeah, just demonstrate that here. Our output is 32. So what we're doing is 1, 2, and 3 multiplied by 4, 5, and 6. And so yeah, 1 by 3. And so it's just taking the values, you multiply 1 by each value here, 2 by each value here, 3 by each value here, and then add them all up, and that should be 32. So that is covered here. So we just get, again, a vector, size 1, 32 is the value. So also one thing that makes NumPy different than MATLAB, in MATLAB, I believe both dimensions have to be the same for you to add matrices. And NumPy, only one dimension has to match, and then something called broadcasting will occur, where basically the size will be matched across the index that doesn't match. So I'm sorry if that doesn't necessarily make a bunch of sense, but I hope I can just demonstrate with this example. So here we're adding the row vector to the matrix. And so the row vector is 1 by 3, the matrix is 2 by 3. And so really we're adding something of size 1 by 3 by something of size 2 by 3. And so what NumPy is doing is basically broadcasting 1 over the 2 rows of the matrix. And so this is called broadcasting, and it's something that MATLAB can't do. So not tremendously useful, but just to show y'all that this makes sense mathematically, we're taking 1, 2, and 3. And so instead of just adding to the first column, which would happen if it was like a 1 by 3 vector added to a 1 by 3 vector, here it's a 1 by 3 vector added to a 2 by 3 matrix. And so 1, 2, and 3 will be added to 1, 2, and 3. And then 1, 2, and 3 will also be added to 4, 5, and 6. So here, 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6. And so we can see 1, 2, and 3 were added to the first row in our matrix, but also is added to the second row. So 1 plus 4 is 5, 5 plus 2 is 7, and I think you kind of get the gist. So instead of it just being added, like in MATLAB, it would say like, oh, your dimensions don't agree. But in NumPy, it'll just broadcast that across the matrix. And then I'm just going to go over how to initialize matrices. So to initialize a matrix of zeros in NumPy, you can just do np.zeros, and then you have to, it takes a tuple as an input for the shape. And so you can't do 3 by 3. That will yield an error. You have to do 3 by 3 as a tuple. So it has to be in the parentheses and there has to be a comma. So I'm just going to demonstrate what happens if you don't have this set of parentheses. You get an error. Data type not understood. That's because we're passing an integer instead of a tuple. So keep that in mind. But run it again as a tuple, no error. So 3 by 3, we're specifying a 3 by 3 matrix, and it's just a matrix of zeros. So that's all there is to that. Also, I like EYE will yield the identity matrix. So if you haven't taken linear algebra or EA1, you may not know what the identity matrix is, but it's just a matrix of ones across the diagonal. And so here we're specifying an identity matrix of 3 by 3. And so there's just a 1 value in each of the diagonal entries, which is where the number or where the index of the row is equal to the index of the column. So 1 by 1, 2 by 2, 3 by 3. Reshape is a method that's essential for pre-processing with machine learning projects. So here we're taking the shape, I apologize, of our column vector. So that's 1 by 3. We are reshaping, wait, hold up. Yeah, we're reshaping to 1 by 3. So yeah, our column vector is 3 by 1, and then we reshape to 1 by 3. So notice that we just do column vector dot reshape, and then you just specify the dimensions that you want to reshape to. But keep in mind, like the dimensions must be like equal to what you started with. So you can't do like 5 by 3. It's got to be 1 by 3. And then we take the shape of our column vector again. We can see that it changed from 3 by 1 to 1 by 3. Or you can do like 5 by 4 or something crazy. So again, y'all may not be familiar with linear algebra, but if you transpose a matrix, that means you change the index of each row and column. And so if you're looking at a matrix, the first, you start with, it's m by n, so it's rows by columns. And so this is the 1 by 1 entry. This is the 2 by 1 entry. This is the 3 by 1 entry. And so if you transpose a matrix, basically 3 by 1 gets switched to 1 by 3. And so instead you would go over here. So this is 1 by 3. So I know the zero matrix and the identity matrix are not a great example for that because they don't change after taking a transpose, but I'll demonstrate it here. So I just named this T matrix, and so this is a 3 by 3 matrix of row 1 having 1, 2, and 3, row 2 having 4, 5, and 6, and row 3 having 7, 8, and 9. So first I'm just going to print the T matrix, and so you can see that there pretty clearly, and then we're going to take the transpose of it. And so 7 is 3 by 1, but after taking the transpose, that becomes 1 by 3. So you get 7 up here. 8 is 3 by 2. 8 then becomes 2 by 3, and then so on and so forth. So all you need to do to take a transpose using NumPy is you just need to take a NumPy array and then .t. If you used a list or something that isn't a NumPy array and you used a NumPy array method on it, it is not going to work and you're going to get an error in your code. So here I'm just going over some basic methods for NumPy arrays, and then that will be the end of this first workshop. So max will return the maximum value from an array. So let me just run this. So first, actually I'm just going to get rid of matrix here since we've seen the matrix enough, and that output confused me initially. So max will return the maximum value from an array, and so we're passing our matrix, or I specified matrix max to be numpy.max, and then we are passing our matrix to max. And so in our matrix, the highest value is 6, and so max will return 6. So it's the highest value in the matrix, not the index of the highest value in the matrix. And then minimum will return the minimum value in the matrix. The smallest value we had in the matrix, as you can see up here, was 1, and so minimum returns 1. But if you use argmax and argmin, that will return the index of the maximum value or the index of the minimum of a matrix. And so since things are 0 index, even though we have 6 values in the matrix, it's 0 to 5. And so the index of the last value in the, or of the highest value in the matrix is 5 since it's the last one. So like 6 is our highest value. It's the last element in the matrix. And so here we're returning the index of that. So instead of the value, we're returning the index using np.argmax. And then argmin, we're returning the index of the minimum. 1 was the lowest value in the matrix. It was the first element in the matrix. And so that's returning 0. Yeah, ignore this code. I'm just reshaping column vec and row vec to actually be a column vector and a row vector because I used them for reshaping earlier, but reshaping is very important. Now to do it, and so instead of using at, you can use np.dot for matrix multiplication. So again, just showing another example of matrix multiplication. 1 by 3 times 3 by 1 will yield 1 by 1. And then you can also take a 3 by 1 and a 1 by 3 to yield a 3 by 3 output. And so here we're taking our column vector, which is 3 values in a column, so it's 3 by 1, and then multiplied by our row vector, which is 1 by 3, and so that yields a matrix of size 3 by 3. So this was just a basic introduction to Python and some matrix properties. Um, yeah. So the whole point of broadcasting is that a smaller matrix can be, like, let's say you had like, actually, it's you have to use a vector. I don't think it would work with a matrix. I don't think that would work, or it would. It's I think it's either just with a vector or it has to be a multiple, but I'm pretty sure it's just a vector. I don't know off the top of my head, but I'm pretty sure it's just a vector. Like, let's say you did like a 2 by 3 matrix and then a 3 by 3 matrix. I don't think it would broadcast across that, if that makes sense, since you'd have to repeat it twice. And so um, broadcasting should just be done with one row and a matrix, like you said. Yeah. So if anyone else has any questions, let me know. I'm going to stop recording now.